Hey, today I'm going to work on two-step equations. I'll do just a few with you, I think 4, and then I'll have my worksheet with the answer key in the room, and you guys can ask for help with whatever you need. I hope this helps. Okay, this is very, very similar to the one-step equations, except this time, right, there's 2, and the order matters, okay? The goal is the same. I always want to isolate whatever the variable is. This equation means 134 equals 9 times some number plus 8. Okay, so what number times 9? Add 8 and it equals 134. Now I have to get A by itself. I know that 9 mashed next to A means multiply. Multiply is in between there. And I've got addition. So I look at this and go, I need to get the A by itself. I have to get rid of the 9 and the 8. I have multiplication and addition. Which operation do I do first? Which number do I get rid of first? The 9 or the 8? What we're going to do is always undo the add and the subtract first, and then we'll undo the multiply and the divide second. Okay, so I look at this. I've got 9 times A, add 8. The opposite, which is also called inverse, opposite operation of add 8, opposite to add is subtract. So I'm going to subtract 8 from both sides of the equation. Plus 8 minus 8, gone. 134 minus 8 is 126 equals 9. This is 9A, which means 9 times A. Now I ask, what is the inverse, the opposite operation of multiply? Opposite of multiply is to divide. A equals 14. Okay, so the big takeaways on this, when you have the choice of multiply or add, you always add, do the addition, opposite to the addition first, and then you have to do opposite to the multiplication second. Okay, let's look at number 2. This one again, I draw my line. I want to isolate the M. That's my goal. So you can even think like cover up that side, right? And you just look at what's with the M that you have to get rid of. I have to get rid of this divide by 5 and this add 6. Well, according to what we said before, we always get rid of the add subtract first. That's the operation we use first. And then we use multiply divide second. So in this one, to get rid of plus 6, I'm going to subtract 6. And I have to subtract it from both sides. These will be gone. 10 minus 6 is 4. And I get M divided by 5 equals 4. This is still my equals. I draw my line. I want the M by itself. I have to get rid of 5. The inverse or opposite operation to division, opposite to division is multiplication. So I multiply both sides by 5. And I get M equals 20. Let's check this one just to see if it makes sense. Is it true 10 equals some number divided by 5 plus 6, that some number is really a 20? Well, let's check it out. 10, does it really equal 20 over 5 plus 6? Well, I do division first. 20 divided by 5 is 4. 4 plus 6, does that equal 10? Da, 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 da. It does. We did good. Okay? Oh, here we go. Distributive property. We haven't done that for a while. This means multiplication in here. There's a multiply. Whenever the 3 is mashed next to any number, variable, parentheses, it's multiplication right there. So I'm going, this means 3 times everything in the parentheses. I have two terms, -7 and x. The terms are separated by a plus. The problem says 3 times -7 added to 3 times the x. This 3 gets multiplied by everything in the parentheses. So 3 times -7 plus 3 times the x. Three times -7 is -21 plus 3x equals -63. Now, I could ignore this side and just go, okay, I have to get rid of the 3 and the 21. I want to isolate the x. This is plus, this is multiply. According to what we've said, we always add, subtract first, multiply, divide second. So I'm going to, this one's a little tricky. It's two terms, and I've added this -21 to the 3x. I'm going to read it again. -21 plus 3x equals -63. To get rid of this -21, I add 21 to both sides of the equation. I get 3x equals -63 plus 21. I'm in debt, $63. I have 21. So it means I'm in debt $42. Okay? Now this is 3 times x. Inverse of multiply is divide. I divide both sides by 3. And I've got 42 divided by 3. So, and notice it's negative, so x equals -14. Okay? So this time we added distributive property on our list of directions. So first, distributive property. Second, we undo addition and subtraction operations. And third, we undo the multiply and divide operations. Okay, we're going to do one more problem. I think it's hard, and there are a couple of them on this sheet. So I'm going to move my sheet up. We're going to do number 13. This one's very different from what we've done. This time, I'm going to read it first to make sense of it. Some number plus 2, all of this divided by 7 equals a -2. Now, before when we did division, only, like if I look at this here, number 10, only x was divided by 2. So in this one, I subtract 10, okay? This will be gone. I'll have x divided by 2 equals a 2. Then I multiplied both sides by 2. This problem here is very different from this. On number 12, only x was divided by 2. When I look at 13, all of x plus 2 is divided by 7. It's kind of like they're trapped. And in order to untrap them, to free them, I have to get rid of this 7 first. All of this is divided by 7. So to do that, I have to multiply each side by 7. And these 7s will cancel. Now this x plus 2 is free from that 7. -2 times 7 is -14. I still need x by itself. I have to get rid of that plus 2. Inverse or opposite operation to add to is subtract 2. So I get x equals negative 16. Let's check this one. See if it makes sense. Is it correct? So I've got x plus 2 over 7 equals negative 2. If I take this negative 16 and replace x with negative 16, is it true? Negative 16 plus 2 over 7, negative 14 over 7, that is negative 2. So does negative 2 come out to be negative 2? Yes. So that means our answer, the work we did, is correct because it does make this statement true. What number plus 2 all divided by 7 equals negative 2? Well, that special number is negative 16. Okay, that gives you one example of each problem. Again, the answer key's in my room. If you want help, ask and check your work to make sure you're doing it. Good job, you guys.